In this video, I will do example 8 of related rate word problems. So in this example, it's involving a street light. So example 8 says, a street light is mounted at the top of a 15-foot tall pole. A man is 6 feet tall, walks away from the pole with a speed of 5 feet per second along the street path. How fast is the tip of his shadow moving when he is 40 feet from the pole? So this is a street light problem. So let's draw our image. So let's pretend we have a street light, right? Okay, and here's a street light lamp. Right? It makes light. And they say that the street light is, or the pole is 15 feet tall. So this length here, just the pole, is 15 feet. And you are, you are 6 feet tall. Okay, yeah, so your length here is 6 feet tall. And we are trying to figure out how fast is the tip of the shadow moving when he is 40 feet from the pole. So somehow this forms a right triangle, or actually two right triangles. Okay, so let's see here. They're saying how fast is the tip of the shadow moving when he is 40 feet from the pole? So that means that this length here is 40 feet. So a little bit about shadows. If you face the sun or light, the shadow will go behind you. And if you're facing away from the sun, the shadow will be in front of you. So let me write this out. So if you face the sun, or light, the shadow will go behind you. If you're facing away from the sun, the shadow will be in front of you. Okay. So so we could say that the shadow is in front of the man. So here's the shadow. The shadow is in front of the man. Okay, so we have two triangles now, two similar triangles. 15 feet. And then This length here is 6 feet. This is X and this is 5. So yeah, we have two similar triangles. So the bigger triangle or the main triangle is this length. It's 15, and then this entire length here is X plus this should not be 5x plus the side, the shadow, right? We don't know the length of the shadow, so yeah, it's not x plus 5, it's x plus s. And then the smaller triangle is this one, right? So this is 6 feet, and then this is the shadow. Okay, now what are we trying to find? We are trying to find yes, that's a good question. What are we trying to find? How fast is the tip of the shadow? So I think we have to find ds dt. Uh, yes, we are trying to find the speed of the shadow, ds dt. Okay, so let's make 14. Oh, and then what else do we know? We know that the speed of the man is 5 feet per second. Speed of the man is dx over dt, and that is 5 feet per second. Okay. So let's kind of like set up a proportion. So let's look at our triangles. What kind of proportion? How should we set it up? Well, we have the height and we have the base. That's all we have. So maybe we should just set it up as a proportion. As so, this is how you would set it up. This, and then the bigger triangle. It doesn't matter as long as the units are the same. So it doesn't matter what triangle you use first. As long as this is the length on the top is the height, and then the bottom is the base. You can't switch the orders. So maybe you could say in the smaller triangle the height is 6, and then in the bigger triangle, uh, so on the numerator this would be the smaller and then bigger on the bottom. So on the bigger triangle, the base is x plus s. I mean, not uh, wait. So you can set it up like okay. So on this side, this would be height. So the smaller triangle is 6, and then the bigger triangle, the height of the bigger triangle is 15. And then in the smaller triangle, the the base is so wait. You could so if this is height and then this is base, um you can actually do it like this, sorry. So if you stick with the smaller triangle first, the height is 6, the base is the shadow, which we don't know. And if you look at the bigger triangle, the height is 15, and then the base is x plus s. So if I cross multiply, I'm going to get 6 times x plus s, and then this would be 15 times s is 15s. Okay, then what I would do is maybe FOIL this out. So this would be 6x plus 6s, and then this is 15s. Okay, then maybe I would get all the s's on one side, so maybe I would subtract 6s. So this is 6x equals 15 minus 6s is 9s. And then maybe we should find the length of the shadow, so maybe I should solve for s. So to solve for s, I would have to divide both sides by 9. So you get s equals 6 over 9x. And then I guess this could be reduced by 3. So 6 divided by 3 is 2x. And then 9 divided by 3 is 3. So yeah, the side length is 2x over 3. Okay, then what we have to do is we have to find, so what we're trying to do is find the speed of the shadow, speed of the shadow. So okay, so how do we, so the speed of the shadow is x plus s, right? And we said that the s is 2x plus 3. So x plus s, which is 2x over 3, which is, if you clean that up, LCD is 3. That would be 5 third x, right? And then basically we just take the derivative of that. So what's the derivative of 5 third x in respect to time? It would just be 5 third and then dx dt. Do we know what dx dt is? I think so. That was 5 feet per second. So it would be 5 thirds times 5 feet per second, which is 25 feet over 3 seconds. Okay, so we just found the speed of the speed of them speed of the shadow, which is 25 feet over 3 seconds, right? So they're asking how fast is yeah, the speed of the shadow is uh dsd. So the speed of the shadow, or ds or dt, is 25 over 3 feet per second. Okay, so that is example 8. Okay, I'm going to stop here.